Alright, we're going to do probability of draws without replacement, or no, with replacement, I'm sorry. This is a very simple concept, one of the easier ones. An urn contains 8 white and 7 green balls. 4 balls are drawn randomly from the urn in succession with replacement. And that's the key here. Because it's with replacement, it means we pull out a ball, we look at its color, we record the color, we put it back, shake it up again, and our next draw comes out randomly as well. So the state of the urn is the same before and after each trial, after each little trial there. What is the probability that all 4 balls drawn from the urn are green? So we have 8 white, 7 green. It's very easy. I'm going to take a little picture and pop it right here. Okay. Oh my goodness. That was loud. And that was my dogs going crazy because my wife got home. An urn contains 8 white and 7 green means that in the urn there are 15 balls total. The chance of picking any individual ball is 1 out of 15. The chance of picking a white ball is 8 out of 15. And the chance of picking, so we'll call that P of white. And the chance of picking a green is 7 out of 15. So what do we want to do? We want to know the probability that all 4 drawn from the urn are green. Okay. Well, we have a 7 in 15 chance on the first time, a 7 in 15 chance on the next, a 7 in 15 chance on the next, and a 7 in 15 chance on the last draw. The probability doesn't change because they're independent, and we can use the multiplication rule because they're mutually exclusive. So I'm going to multiply those. So the answer is the same as 7 over 15 to the 4th power. Okay, so I have a calculator available to me and Alex, and I'm going to use it. So we hit calculator, and we're going to type in 7 divided by 15. You got to hit arrow over to the, that's x, that's the x to the y button, brings that up, okay, to the 4th power, enter. And we're going to round this to 3 decimal places. So 1, 2, 3, look at the number after the 3rd, and it's lower than 5, so we're going to keep the numbers the same, so it's 0.047. And that's it. Very good. I seem to have mastered this. Well, I don't want to have mastered it yet because we're going to review it again. So let me hit review. And we're on chapter 4. We're doing probability of draws with replacement. Okay, an urn contains 7 green and 9 white. 5 balls are randomly drawn from an urn in succession with replacement. What is the probability that 5 balls drawn are all green? So we have a 7 in 16 chance, but we're going to do it 5 times in a row. So it's 7 over 16 to the 5th power will be our answer. It's pretty straightforward. All the problems, though, are not this straightforward. And I'm hoping the next time I hit a new one that one of those ones will come up. So let's move this over. 0.016 is our answer. 0.016. Alright, next. More practice. Here's the one I was hoping for. I'm going to copy this one. A fair die is rolled 5 times. A die is considered to be with replacement because all the numbers there at the beginning are still there at the end. So before you roll and after you roll, the die is the same and all the probabilities are the same on that die. Your chance of rolling any particular number or not rolling it is still the same. So the question is, what is the probability that a 5 is obtained on at least one of the rolls? Well, at least one isn't always easy to do. So instead of finding the probability of at least one, we're going to find the probability of its complement. The complement of at least one is none. If we find the probability of no 5s being rolled, then that is going to be the complement of at least 1 being rolled. Okay, keep that in mind. The complement of at least 1 is none. And this is a lot easier to figure out because otherwise we'd have to use the addition rule and figure out what's the probability of 1 being rolled, what's the probability of 2 being rolled, what's the probability of 3 being rolled, what's the probability of 4 5s being rolled, what's the probability of all 5s being rolled. And that's no fun. Let me write that down though. In order to figure out at least 1, P of at least 1 5 is equal to the probability of 1 5 plus the probability of 2 5s plus the probability of 3 5s plus the probability of 4 5s plus the probability of all 5s. And you can see that's pretty much every possibility except for 1. This leaves out the possibility of no 5s. And that's because no 5s is the complement of at least 1 5. Does that make sense? So P of no 5s, all of these would add up to 1 because they are every possible outcome. So if we want just this side over here, we can go 1 minus P of no 5s because that's the complementary event. And P of no 5s, well, our chance of rolling no 5s on any particular roll is there's 5 other numbers out there and there's 6 possibilities. So we have a 5 in 6 chance on each roll, and we're going to roll 5 times. So our answer then for P of at least 1 5 is 1 minus 5 over 6 to the 5th power, which we can do very quickly with our Alex calculator. Calculator, 1 minus parenthesis 5 divided by 6, arrow over, close the parenthesis, to the 6th power. Is it? Nope, 5th power, my bad. Alright, enter. That's our answer. 0.598. Look at the number after the 8. It's a 1, so we don't round it up. 0.5. Oh, I gotta write it down here. 0.598. And that's it. That's how you do that. We'll look at one more because I think we have time. So I'm going to have to go through this review thing again and scroll down. If fair die is rolled 6 times, what is the probability of having no 1 and no 2 among the rolls? Okay, if we're trying not to roll 1 or 2, there's 4 ways not to roll a 1 or a 2. You can roll 3, 4, 5, or 6. So there's 4 ways out of 6 to successfully not roll a 1 or a 2 at any given time. So we have if we were just rolling the dice once, we'd have a 4 out of 6 or a 2 out of 3 chance, but we're rolling it 6 times. So we have a 2 out of 3. Oh, whoops. Let me put it in parentheses. 2 divided by 3, arrow over. We're doing it 6 times, so to the 6. To the 6. And there's my answer. It's 0.087 with a 7 following, so we're going to say 0.088. That's it. Now I think I've shown all the kinds they can give you, so I hope that was helpful, and we're going to say we're done both with that and with the video. So